Here's our next transformation, rotations and symmetry. So we've talked about translations, we've talked about reflections, and now we're going to talk about rotations. So today we're going to talk about rotations and symmetry. First, a rotation, guys, is a transformation in which a figure is turned about a fixed point called the center of rotation. So you have a point at which you're kind of circling the shape around. So this kind of a turning or a spinning is a rotation. Okay, just like cars rotating, the wheels rotating. That's a rotation. Okay. You can have rotational symmetry, which most people don't think about. Most people think of like a line of symmetry, like reflection, but you can have rotational symmetry, and that is a figure that can be rotated at 180 degrees or less about its center, and it looks like the same shape as it's rotated. So depending on how specific you wanted to get, like a car tire looks like a car tire no matter when you stop it. Now if you get specific with the writing on the tire that's in there, then it wouldn't be. But some shapes can rotate and look the same even when it's rotated. Others cannot. So those are our two definitions for today. If you need to pause, go ahead. Otherwise, I will be moving on. In our first example, we are going to talk about rotational symmetry. So when we look at these shapes, we want to see if I rotate the shape, does it look exactly the same? And then what I want to do is tell the angle at which that occurs. It could occur and if it's 180 degrees, it'll just be 180 and then 360. If it happens at 90 degrees, it'd be at 90, 180, 270, and back to 360 degrees. So whatever angle it happens at, it's going to be that angle until it gets back to 360 degrees. Okay, so in example A here, we have our flag. Now when I'm looking at this flag, if I rotate it 90 degrees, okay, then the center part is going to look the same. However, it's a rectangle, so 90-degree rotation in a rectangle is not the same, okay? It's going to go from short and long to, very thin to tall. And so that's not going to work. But if I spin it all the way around completely, from the top to bottom, right to left, then it'll work. So this has rotational symmetry. Okay, so it has rotational symmetry at 180 degrees. Okay, so at 180 degrees, it looks like the same shape. Every 180 degrees you turn it, it'll look like the same shape. Okay, in example B, when I look at that, all right, it's a rectangle, so I'm really spinning anything less than 180, and it's not going to be good. So when I do 180, it's not going to be the same because the blue part is going to end up over here, so it won't look the same. So this has no rotational symmetry. No rotational symmetry. Okay, and then in our last example, example C, we have a square. So in a square, if I rotate a square, so I take this corner, let's say I rotate that corner over there, that corner over there, that corner over there, and that corner over there, it's going to look like the same square. How many degrees is that? That is 90 degrees. So this has rotational symmetry at 90 degrees. Now I decided to turn mine kind of turning to the left, which is called counterclockwise. But you could also turn it to the right, which would be clockwise, and I would still get 90 degrees. So every 90 degrees, no matter which way you turn it, it has rotational symmetry. And so that is identifying rotational symmetry. Okay, if you need to pause, go ahead. Otherwise, I'm going to move on to our next slide. In our next slide, okay, it is very, very, very important that you write this down. Okay, how to rotate a figure. There's three ways that we can rotate a figure that we're going to talk about in class. You could do other degree of rotations, but that gets much more complicated. We are going to talk about a 90-degree clockwise rotation, so that's kind of going to the right. Okay, and we're going to talk about a 90-degree counterclockwise rotation, so that's kind of going to the left. And then we have a 180-degree rotation, and that's kind of flipping the object over to the other side. So we have those types of rotations. Now we are going to be rotating it on a coordinate plane. So when we draw these, we'll be working with the coordinate planes and the coordinates. So when I'm rotating it all of ours are going to be about the center or the origin of our coordinate plane. So we aren't going to be rotating in the middle of our coordinate planes, in the middle of a quadrant in our coordinate planes. We will only be doing it in the center. And that, if we use the center as our center of rotation here, then I can follow these rules. So these are kind of rules that I that we have here that we can use. Okay, and so you definitely want to make sure you write down these rules because they're very important and they're going to make your life a lot easier when trying to regraph these. Okay, in our first example, I'm going to talk about 90-degree clockwise rotation. So let's kind of take it to the right a little bit. I take my coordinates, so x, y are my coordinates of my original shape, to find my new coordinates of my figure. Okay, so this is going to be my image when I draw it. So to find my image, what I am going to do is I'm going to switch the coordinates, whatever the numbers are in the coordinates, I am going to switch them, okay? And then what was the original x-coordinate, which is now in the y spot, I am going to take the opposite of whatever sign it is. So the negative that you see in the image part in the second half, that negative that we have right here, that is telling you to switch the sign. So when you see that negative, that means that we're going to switch the sign. So if it's negative, it becomes positive. If it's positive, it becomes negative. Okay? So it's just kind of weird to do with the x and the y, but you're going to switch the numbers, the original numbers, you're going to switch them. Okay? And then you're going to take the opposite of the new x value. Moving on to our 90-degree counterclockwise rotation, you are going to do the same thing. Okay, this is taking us to the left. We're going to do the same thing. We're going to switch our x and our y coordinates, except this time, the old y coordinate, the new x coordinate, we are going to take the opposite of that number. All right, so we're going to switch the numbers where they belong, and then we take the opposite of the old y, the new x. All right, and a 180-degree rotation is a little easier. All you do in a 180-degree rotation is take the opposite of the numbers. So they don't switch positions at all. We just take the opposite of each number. If they're positive, they become negative. If they're negative, they become positive. So make sure you write down these rules, because in the next slide, I'm going to go over an example of how to go through these rules and follow them. So you want to make sure that you have these rules written down, and as you're working on your target practices in class, that you're looking at these rules, because it's a lot harder to try to visualize turning these figures than it is to do the rules, write the coordinates, and then regraph it. Okay? If you need more time writing those down, go ahead. I am going to move on to the next slide. All right, so here is our example. First, I have a triangle ABC with vertices A is negative 3, 4, B is negative 2, 3, and C is negative 2, 1. Okay, so I'm going to scroll this down a little bit just so I can still see the vertices. Okay, and now I'm going to go through and I want to rotate the figure 90 degrees clockwise, 90 degrees counterclockwise, and 180 degrees. And we're going to write the coordinates of each image. So we're going to have 3 images on this one. Okay, first thing I'm going to do is I'm going to graph my image. So I have negative 3, 4, so I go to negative 3 up to 4, and that's A. And then I have negative 2, 3, so I go negative 2, 3, and that is B. And then C is negative 2, 1, and that is C. And we have to draw really sharp lines here because that looks really small. So there is my original figure, and I don't know why C has ended up way over here. That was, messed that up. So let's go back to our point, and we'll make that C. There we go. Okay? Now, I am going to rotate that figure, okay, clockwise 90 degrees first. So clockwise, remember, okay, we have our x, y, and that turned into y negative x. So what I am going to do, looking at A prime here, my new figure, okay, it was negative 3, 4. So I'm going to switch those. So the 4, which was the y, is now going to go in the front. And then the negative 3 is going to go to the back, and I'm going to take the opposite of it. So it was negative, now it becomes positive. So it's going to be 4, 3. Okay, my B prime, I look at my y now goes to the front, so that was 3. And then my x coordinate goes to the back, that was negative 2, and I take the opposite of it. Now it's positive 2. And then my C prime, when I look at my C prime, okay, my y, my 1, oops, sorry about that. My 1 is going to go to the front, so that becomes 1. And then my negative 2 is going to go to the back, and I take the opposite of it, and that becomes positive 2. So that's going to be 1, 2. Now I can graph these points. So I go to 4, 3, 4, 3, and I go to 3, 2. Well, that's A prime. Well, I'm just going to do them all first. I go to 3, 2. That is B prime. And then I go to 1, 2. and that is C prime, and then I draw my shape. Okay, probably should have picked a shape that was a little bit bigger here. Okay, and there is my figure. Okay, now let's move on to our 90-degree counterclockwise. In 90-degree counterclockwise, I'm going to draw my figure. So my counterclockwise, remember, was xy, and that was negative y, x. So I'm going to do the same thing by switching them, except I'm going to take the opposite of now the y that came into the front. So this is going to be a double prime. So I'm going to move my y to the front and take the opposite. So the 4 goes to the front and becomes negative 4, and then the negative 3 goes to the back and stays at negative 3. Then I'm going to do b double prime. The 3 is going to go to the front and then become negative 3. The negative 2 is going to go to the back, and it's going to stay at negative 2. And then I'm going to do C double prime, and in C double prime, the 1's going to go to the front. I take the opposite, so it becomes negative 1. Negative 2 goes to the back and stays the same. Now I'm going to graph this image. So A double prime is negative 4, negative 3. Okay, B double prime is negative 3, negative 2. And C double prime is negative 1, negative 2. So when I do that, I have, here's my A double prime, B double prime, and C double prime. Okay? Now I have my 180-degree turn. So my 180-degree turn, guys, remember, all I do for my 180-degree turn is just make them the opposite of what they are already. Okay? So I'm going to move down. I'm going to have to remember my initial things here so I can see them. So my first one, A triple prime. That was negative 3, 4, so that's going to become positive 3, negative 4. And then I'm going to go to 3 triple prime, and that is going to be, that was negative 2, 3. Now that's going to be positive 2, negative 3. So I'm just switching the signs. Okay, and then I'm going to go to C triple prime, and when I do that, it was negative 2, 1. Now it's going to become positive 2, negative 1. Now I can graph that. So we're going to have 3, negative 4. You are going to have 2, negative 3, and you're going to have 2, negative 1, and when you graph those, there's your shape. So this is going to be A triple prime, B triple prime, and C triple prime. Okay, and it's kind of hard to see, okay, but if I look at the shape, all right, in here, and that first one's not very good, if you kind of watch the shape kind of circle around here, and imagine it flipping as you're circling around, you can see how the C point kind of rotates, all right, and how it fits in here, okay? And you can kind of watch the B point and see how it circles around there and how it's rotating all part our center of rotation there, okay? Or you can visualize it going the other way. So when we write these, they're really hard though when you look at them. They don't really line up where you would think they would line up. But if I were to take quadrant 1 and turn quadrant 1 90 degrees and slide it over to quadrant 2, okay, so quadrant 1 to quadrant 2, the shapes would lie on top of each other. And then if I did it again for quadrant 3 and then quadrant 4, they would all lie on top of each other. It's really hard to visualize a lot of these, so writing your coordinates out first and then graphing them is a lot easier to do. Okay, that is our lesson for tonight. We will work on some of these practices tomorrow in class, and have a great night.